you doing?
All right, who took an AP class yesterday? How did it go?
I thought it was really well, but then I realized that like the pass rate is like 51%. And like thinking that half people in the room are gonna pass, half of them are gonna fail, looking around and seeing like Allie Levy, I was like,
Now there's a little bit of flawed reasoning there. 50% pass rate among Greg's students, or nationally?
That's different. I don't know. Yeah, but my she told us
Greg is an above average teacher.
We were down there. She said we were close, like skipping passing. She's not
Just show us what's the percentage of passing for count?
Nationally or in here?
Both.
I should know that.
I should.
Can you Google it?
What is the national average from last year? Mr. Wood He knows all the national facts right. He knows everything.
Yeah, Mr. Wood would know.
That's the 5. That's the 5.
That's a 5.
That's a 5.
What are you talking about?
Look, it says
That's
5.
the BC AP subscore.
Oh, 5 or 8.
Yeah. See, here's the 5. Oh, okay.
61.4%.
All AP classes is really a 71.
All right. Last year, about 85% of my students passed it. It's up and down though. Some years ago. Yeah. Oh yeah. Yeah. There might have been like a 1, a couple 2s, but then like quite a few 5s. See, here's what else isn't taken into consideration. Any of my students who take the BC test aren't in that group of passing. They're, believe it or not, they're not actually my students.
Any ones?
Mm-hmm. There was like one or 2. All right. Today.
Who was it?
Like the title? Random Review Day. I have no idea where we're going. You guys lead the way. What would you like to review today? So you name a topic. Now, first of all, before we do that, you're supposed to come. Those of you who are here, we're supposed to come with some topics to review. This is due late in the week / early next week. This is your year-long average. This is going to replace your final exam if you choose to accept it. All right. Normally, you double every marking period and then count each exam once and then divide by 10. That's your year-long average. Since there's no final exam, there's one fewer parts that it's out of, so you divide by 9 instead. Don't count, obviously. There's no final exam to count in there. So you're going to calculate that. We'll have a day or part of a day where we confirm, that this is what I'm getting as a calculation, and then I agree or disagree with it. And I just want to make sure we're on the same page there. Just that way. Here's the tricky thing. End of the year, our window of getting things done is complicated by a couple things. 1, time, and 2, how much I see you, right? These last couple of weeks, I don't see you a whole lot. And 2, the time thing, the administration wants senior grades, especially those who are in the top 10, top 5, I forget what it is, finalized very quickly. And so we need to be on the same page, and it's best if we just kind of go over that together and make sure we take some time to calculate that and agree on what you are possibly replacing your second semester exam with. All right? Questions on that? Everybody understand how to do it? All right. On your end, is it pretty easy to find those in Canvas? Is that where you go? Canvas? So it already has that calculated?
Like if you go into like your Canvas page and you click all for your grades for calculating.
Oh, nice. Thanks for sharing that. I don't get to see that end of it. All right. What would you guys like to review? Topics. Pete. Linearization. Oh, come on. I even closed all my tabs right before this class just so it'd work.
Quick restart.
Huh?
Quick restart.
Restarting computers is overrated. Do I need to restart?
Probably.
That's what Jen is.
Well, my battery, I was working on something 2 nights ago and it said 35% battery remaining. And then like 5 seconds later, shutting down. So I restarted then.
If you ever got a problem with it, just restart it. Pull up your task manager. See like.
What's up?
Pull up your task manager. See like check the runtime.
I just did that last period. It's like,
What's your like CPU usage?
what is that thing? What just happened?
Put in the admin.
It's just at 100%.
Your CPU is only at 100. That should not be anywhere primary 100.
Like, right. Like, I just closed. Chrome was hogging like 60%. So I closed it.
Yeah,
But, like-
that shouldn't be close to 100%.
Why is it saying 100? Like, if you add all these up, it's not 100.
Slow down. Light burn.
Yes, let us review.
Try just restart. I think
Trying to learn what you.
Alright.
Off topic. I won't listen to Woody. Your CPU should never be around that.
All right, linearization. Try those two. All right, Peyton, how much of it do you remember?
I remember it. I just don't know how to do it.
Gotcha. Okay, so general idea, some function, f of x. And we've got a, we've got f of a. And something you should know, I mean, we talked about this in an FRQ problem, is that anytime you have a tangent line, f of a and L of a are the same. Why? I mean, that's the definition. The tangent line touches the function at that point, they share a point, and they share a slope there. So if you find the derivative of f at a, that's called f prime of a. You also have a point a, f of a. You can write the equation of the tangent line from that. Now, in the linearization, we called it L of x. It's not always called L of x. Sometimes it's just a tangent line. But because this has a special application, we called it L of x. And L of x, so y, L of x, y, minus y1, well, that was f of a, equals m, f prime of a, times x minus x1, which was a. This is a fancy point slope form, right? This is the equation of a line with a point and a slope. It's just a fancy point slope form. So here's what we did. We found L of x and we used it to approximate a nearby point, maybe like a plus 0.1. And that blue function, it was too complicated to plug this into without a calculator. We couldn't really do it. So we would plug it into the tangent line, and I'm exaggerating here. These are not going to be that far apart. They would never ask you to move that far away from the point of tangency. It would not be useful, but I'm exaggerating just for the visual here so you can see the actual space between them. This point right here is f of a plus 0.1. This is L of a plus 0.1, and we're going to use that tangent line. We're going to plug in a plus 0.1 into there to see what the height is on the tangent line. Does that make any sense to you? Which part?
Just the. Oh, what are you talking about?
Sorry, I started asking you,
And then I got a reaction from the back row, so then I started addressing them. Which part is confusing?
The last part that you said makes sense.
So what I'm doing today, these are general reviews. Like this is a general review topic. I can't possibly review 4 sections very specifically in a class period. So most of this is going to be general overview. Okay. I can do a specific problem if we need to. But what I'm trying to say is here's the general concept. I don't know why I'm blanking. It's section 4.5. Section 4.5. So page 242. Number 3. F of x equals x plus 1 over x. A equals 1. And the directions say find the linearization L of x of f of x at x equals a. How accurate is the approximation L of a plus 0.1? L of a plus 0.1, which is approximately f of a plus 0.1. Okay, so here's what's going on. To get L of x, we need a point and a slope. Do you agree our x value is 1, right? F of 1. And what is f of 1? 2. What's our slope at that point? Well, we'd need f prime, wouldn't we? We'd need f prime of 1. Well, f prime of x is 1. Yes. What's f prime of 1? This is a bad example. We're changing the problem. I don't know. That's a stupid. It's going to be a horizontal line, and there's no point in it's not a very good example. All right, let's do a equals 2. Things could get messy. I'm warning you. All right, a is 2. What's f of 2? 2.5. Good. All right, what's f prime of 2? 1.75? Yeah. So here's what you do. You need this point. You need this slope. Yeah. 1 minus 1/4, 0.75. We need this point, this slope. So L of x minus 2.5 equals 0.75 times x minus 2. Do you agree? What are we approximating? F of, careful, 2.1. Look, A is 2. They want us to approximate A plus 0.1. We're plugging in 2.1. Ready? 2. We're going over 0.1. We're plugging in 2.1. Where? In for x, right? Aren't we approximating L of 2.1? Now, here's the benefit of leaving it like this. What's 2.1 minus 2? A tenth. What's a tenth of 0.75? Agree? 0.075. 0.075. Add 2.5. What's 2.5 plus 0.075? 2.575. What does that mean? That means, does someone have their hand up? Okay. We're not there yet. We're not there yet. Ready? 2.1. Which purple dot, the dot on the tangent line or the curve, is the 575? It's on the tangent line. Help me out, was that 575?
Yeah.
This is at a height of 2.575. I don't know how to get the height on the actual function, right? That's the point. Ish. Could I plug in 2.1 into the real function? 2.1 plus 1 over 2.1. Type it in. No, I just made this up. I'm not sure how close it's going to be. 2.576. 2.576. We are 1/1000th off. Doing it in our heads. Now, when I say in our heads, no calculator. Like, just plug it into the tangent line, which is really easy because all you have to do is subtract a number really close by. It's going to be an easy decimal. And then add a constant. Why? Because it's a line. It's linear. So Peyton, to go back to the big idea here, you're using a tangent line for approximation reasons. Because the function and the tangent line have to stay pretty close together if you don't move too far from the point of tangency. All right. Here's what else I've seen them do on the AP test. Here's the pretext here. Let's say a tangent line approximates f for nearby values. What is an approximate 0 of f of x? Well, isn't a 0 of f of x where f of x crosses the x-axis? And if they're telling you the tangent line is a close representation, can't we find out where the line crosses the x-axis and use that in its place? How do we find out where a line, crosses the x-axis? Plug in 0 for y, right? Isn't the x-axis y equals 0? Plug in 0 for y. And so what about this one? Here's my tangent line right here. If I plug in 0 for y, you'd have to do that math. 0.75 times x minus 0.75 times 2, and then get x by itself. X equals blank. Okay. So they might ask you to do different things with that linearization function. All right, we need to move on to other topics. I want to make sure we do more. What other topics? Sydney? Related rates. What are some types of related rates questions we've seen?
Shadow. Water fountain.
I heard someone else say it.
Plane.
Planes? Yep. These are all triangle problems so far, aren't they? Boats. Yeah, with like a rope on a pulley, like being pulled in. Those are all triangle problems. The thing to remember, just an overall review of related rates, okay? You will recognize, I hope, related rates when you read that certain quantities are changing with respect to time. Like maybe it's an x and a y and a z, and they are changing with respect to time, okay? Every derivative in this problem needs to be with respect to time. So here's the general approach to these problems. You organize your information, what you're given and then what you're trying to find. Some values are constant. Some values are changing. Now, I need to be careful with this because when I say some values are constant, I mean always constant. Like, don't judge. There's a light. There's a human being. The light shown down. We have a couple pieces of information here. We have how far this person is from the light post. Let's call it H. We have how long the person's shadow is. We'll call it K. We have the height of the person, M. We have the height of the light, we'll call P. Now, here are some common things that crop up. Are you ready? You may need the Pythagorean theorem. All right. You may need a similar triangle proportion setup. Right? You see the angle similarity in the triangles, angle. So therefore, K over M equals, careful, K over M equals H plus K, that side, H plus K over P. Remember this? Okay. Do you want a scenario here? Do you want me to make up a problem? I'll try. It might get ugly. Someone asked fourth period, and we found one. I'm just trying to remember the numbers. A 16-foot light post, okay, casts a shadow with a person that is 6 feet tall. The person is walking towards the light at 3 feet per second. How should we label that? DHDT equals 3 or negative 3? Is H lengthening or shortening?
Can you technically label it either way depending on how you oriented the situation? As long as you define.
You've asked that already this year.
Yeah, as long as you define one side is negative, one side is positive. It's all just about perspectives.
This is a story of life.
Like how usually left is depicted as negative and right is depicted as positive. But if you look at the scenario where a car, is heading back.
You do what you do. All right. Find the rate at which the shadow's length is changing when, I'm trying to remember. I forget what the given information was, the last piece. I think it's when the person is a certain distance from the shadow or from the light.
I did an AP video on it, and the distance is like 7 feet. And you
Like
had to
7?
find the shadow.
All right. I think it might even be in the book. Should we look it up? Or should we just go with it?
Just go with it.
Look it up.
When is that?
Go ahead and look it up. All right. What's our ratio again? Well, first of all, back up. Yeah, if you have go ahead. I'll keep going. You look it up. Oh, you wanted me to look it up.
Where's that?
4-6.
4-6.
All right, here we go. Am I allowed to call 16 and 6, or do I need to keep them generic P and M? 16 and 6. Why? They're not changing length. The lamp and the person are not changing length. So if I go 6 over 16 equals what over what? 6 over 16 equals I'm setting up a proportion. Setting up a proportion. Equals what? K over H plus K, right? K over H plus K. Who doesn't understand that? Go ahead. Do you see the two? Can you see the two triangles? Ready? Purple triangle, black triangle. Purple, black.
Why isn't it both the heights? Why isn't it 16 over H plus K? And then 6 over K?
I mean, it's all the same.
Yeah, you could do the same thing.
Or is it could be either way.
Okay, go ahead and say what you want and we'll compare. Here's the key. When you cross multiply, are you cross multiplying the same thing I am? So go ahead, tell me what you're going to set up. 16 over H plus K equals 6 over K. Are you going to multiply 16 and K? Are you going to multiply H plus K and 6? Same thing. Fine. There's a bunch of ways to set up these proportions. Okay? They're all going to work if you stick with the correct order. All right, so 16K equals 6H. Oh my gosh, this is so terrible. You shouldn't have to restart your computer twice a day.
I don't think that.
What's up?
I don't think that. No, it's not in the book. There's.
All right, it doesn't matter. It's fine. Stop and ask yourself, what are we trying to find? Now, I'll have to remind you because you don't have the problem in front of you. The question was, how fast is the length of the shadow?
Oh, wait, I found it.
Stop interrupting, will you?
It's okay, but wait, did you reopen the book?
Yeah.
Okay, got it.
Well, it's not like the same one, but it's at what a man 6 feet walks at the rate of 5 feet a second toward the streetlight at 16 feet.
So pause for a second. Walks toward a street light at a rate of
5 feet per second.
So I'm going to change this to -5. You okay with that?
We're not playing.
Then what?
Toward the streetlight at 16 feet above the ground. At what rate is the length of the shadow changing when he is 10 feet
Okay, when he is 10 feet away from the
from the
light.
So it's 8.
So H equals 10.
No.
Are you guys with me?
Yeah.
So what are we trying to find? Find dk dt. dk dt. So why is that important? Well, at this point in the problem, when I cross multiply, what do I want to solve for? solve for k, because when you take the derivative of k, you're going to get dk dt. So isn't 10k trying to do it for people who are watching the recording, but whatever. All right, isn't 10k equal to 6h? Isn't k equal to 3/5 h? Yes? Derivative with respect to time. What's the derivative of k? dk dt equals 3/5 dh dt. Go ahead and ask if you're confused by that. Constant multiple, 3/5 going along with it. What's the derivative of h? dh dt.
One thing I'm gonna say is, how come you bring the h with you, you don't just plug in 10 for h? Is
At
that because it's not
what
constant?
point? Here?
At the, yeah, I mean, I guess.
Okay. If you do it here, then what's dk dt going to be?
It's just
Zero. Because you have, back when I taught this to you, I called it freezing the picture in time. Okay. You know, it was the red light camera analogy I gave you, how the picture gets taken to the license plate and it records the car was going 50 miles per hour through the intersection.
Yeah, but that's changing.
But it's actually changing. We're looking at the picture, but it's actually moving.
Okay.
But what if the car was parked there and it broke down? Yeah, it was running a red light, but it was going 0. It's not that situation. I mean, it's not frozen in time. It's moving. You have to allow it to move. You can't plug in 10 too early. When can you plug in any constants? After you've allowed for it to move. Okay. So dHdt is -5. 3/5 times -5 is -3. So -3 feet per second. 3/5 times -5 is -3. The length of the shadow is decreasing in length by 3 feet per second. At that instant, not all the time, just whenever the guy's 10 feet from the face of the light. I've seen that exact problem. I shouldn't say exact. I've seen one just like that on the AP test. All right, other topics. Annalise. Optimization. Do you want just a topic review? I haven't seen it on the EP test a ton. Can I tell you why? Do you care? Optimization doesn't pop up too much. Do you guys remember what we did when we did optimization? What is the maximum volume that this box can hold? Okay. What is the minimum amount of, the pop can example we did? What's the minimum amount of aluminum surface area, right, that you can use with this volume? Here's what it was. It was find the constraints, like you're given constraints. Maybe they're a fence problem. Maybe there's only 800 feet of fencing to use, but one side's up against the river, so you're not using the fence. So you have a new adapted perimeter, right? And you're trying to maximize the area. Well, maximize the area, that's length times width. My perimeter is 1L plus 2 W's equals 800. You solve for one of the constraints, you plug it into the objective, you maximize or minimize that function. So here's what optimization is. It's reading a problem and then turning it into a first derivative test. Because it's a max or a min. So we got to the point where we had our objective function and then we just looked for a max or a min. So they don't ask that on the AP test too often because all it is, it's a first derivative test. And if they want to test your understanding of a first derivative test, 9 times out of 10, they're going to do it another way. They're going to give you f prime and say how many local maxes are on this graph. Oh, well, there's a local max because f prime changed from positive to negative. Like they can test that way easier in that context than to make you run through a whole optimization problem. And what happens? Students get messed up on this part that had nothing to do with calculus. And so they don't want to do that. This test is all about testing your understanding of calculus, not algebra. There may be a little bit of algebra on there, but I bet you guys have noticed a lot of the questions require very little algebraic work. Have you noticed that? Very little algebraic work. So I can review with you sometime if you'd like, but it just doesn't pop up a ton. Now that I say that, it could, honestly, but at some point you have to play the odds too, decide what you're going to spend your time reviewing. What else?
Could you do like a U substitution?
I would love to.
It's getting back to people keep asking if the meeting's canceled. He's like, I'm in kindergarten right now. You don't have to respond to our text. I'm like,
Lib, you're going to pick one for us.
kindergartners have to push that.
You don't have to do it. You just have to pick one.
Alright, we'll go like number 6.
6?
A bad one.
No, it's not bad. Don't judge his choices.
No, terrible. Hey, Ty, you can pick one out of those.
Ty's all about recommending other people do stuff.
I like to myself.
All right. And since this is an overall review day, here's what I'll say. If you get to an integral problem, there's one of several scenarios that can happen. One, you know the antiderivative, solve it pretty easily. Just antiderivative, don't forget your plus C, multiple choice, pick the right one. Option 2, you have to do a little bit of algebra before you can recognize the antiderivative. Okay? For example, what if you get this? And I'm making this up. It may not be pretty. I'm gonna make it pretty ugly. All right. Do you know that antiderivative? Would U substitution help you here? And you may not know that. How many of you still aren't too sure about that? And here's what you'd ask yourself. By the way, I would recommend not going to U substitution until you've tried some algebra first. Okay, that'd be my third. U substitution would probably be my third approach in the process. But we'll try the algebra here in a minute. But for this example, what would you let U equal?
Squared.
X squared. And then what's du? 2x dx. And I don't see a 2x dx. I see it. And you can't break up this addition and say x dx and just adjust by a 1/2. Do you see what I'm saying? So I don't think U substitution is a very good fit for this one. All right. What was U substitution? Well, we'll get back to this. But let's say we have sine of 2x. Some of you could guess and check at this. How many of you know it right now? Couple. You'd start off by saying negative cosine of 2x. But then if you took the derivative of that, you'd be off by 2. So you have to put a 1/2 in front. So you'd say negative 1/2 cosine 2x plus c. And I would strongly, strongly, strongly encourage you to try to guess and check. Okay, if you don't need U substitution, don't use it. So here we go. Ready? Derivative cosine, negative sine. So that negative and negative make a sine. 2x times 2, and that times 2 and that 1/2 cancel and make a 1 up front. We're good here. This is good. Okay? Could you use u substitution? Yeah, you'd let u equal 2x. What's du? 2 dx. Well, I don't have a 2 dx. I need to multiply by a half. So dx gets replaced with 1/2 du. So I have 1/2 sine of u du. The 1/2 goes along for the ride, even for antiderivatives. What's the antiderivative of sine of u? Negative cosine of u. So negative 1/2 cosine of 2x plus c. So u substitution will work. So back to u substitution. When do we use it? Well, when you have a composite function whose derivative appears elsewhere. Okay? So the nerdy way to say it is you have f of g of x times g prime of x dx. You're going to let u equal g of x. Du is going to be g prime dx. You'll be able to substitute this to be f of u du. So what was the process for u substitution? Is there an inner part? If so, does the derivative of that inner part appear elsewhere? And so here we go. If we let u equal 1 over x, what's du? Negative 1 over x squared dx. Do I have a negative 1 over x squared dx? I do. Kinda, right? I have a 1 over x squared dx, don't I? So how do I adjust this? Multiply the negative over. And so you have secant of u, negative secant of u du. Hey guys, freeze for 1 second. I want to talk about one more thing. This is a rewrite. Negative 1 over x squared plus x over x squared. Do you know the antiderivative of negative 1 over x squared? I did it for a reason. It's 1 over x. Do you know the antiderivative of 1 over x? ln absolute value x plus a constant. That you would do with algebra, right? Good luck on your exams tomorrow.